Welcome to day 2 of lesson 19. So just to kind of go briefly back over what we're talking about the different currents, which ones had cleaning actions, which ones had better penetration, and the general idea of what gas tungsten arc welding is. To continue going on talking about AC welding, which has a positive and negative, we're going to be talking about rectified current. Now, rectified current does not flow in the electrode positive half of a cycle. If you remember with AC, it goes from positive to negative, positive to negative, positive to negative. So when it's going into its positive half, the rectified current does not flow. Sometimes, though, you have a partially rectified current, and this is a less desired flow in the electrode positive half cycle. It needs to be off, it doesn't need to be on. Another thing is that you can have a square wave power supply to allow adjustments for certain things. So here is correcting for rectification. There's no current flow during the positive half of AC, and this is an unbalanced version of that, where it has just a little bit, but it's not as much as the negative side. And this is one where it allows both negative and positive to have the same thing. Now this is good for high frequency, but for regular AC, not so much. So when we get to pulse GTAW, where we have a pulse current, as you can tell, it goes up, this comes down, comes up, comes down. And this is your peak pulse and your background current. So you have your peak pulse current and your background current. And in between, you have your pulse times. So your peak current is your high one and your background is your low one. It generates a series of weld spots. So instead of a continuous weld, it's almost like doing a lot of little spot welds. And this is excellent for out of position welding, because when you're doing it out of position, it makes a little weld kind of stops, a little weld kind of stops, and it allows it to cool down instead of just flowing down into, because of gravity. Now your welding bead impulse GTAW, we've been walking the cup, but as you can tell, this doesn't look like walking the cup. This is more like freehanding and dabbing, which is kind of called laying down dimes, just as a nickname. You see you have a weld, a weld, a weld, a weld, a weld. So there's actually a bunch of tiny little welds on top of each other. And you got to make sure that they overlap, because if they don't, you're going to have structural weak points. So let's talk about the torch functions and what it does. The first thing is obviously it holds the electrode. That is your tungsten. It makes the electrical current contact with the electrode. So this is where your electrical current goes through the lead to your torch, and then it gives it to your tungsten. It directs the shielding gas to the welding area and provides a mean of cooling the electrode. So the gas for ones that aren't water cooled are the ones that actually cools down the electrode. The one that's water cooled is what actually cools down the torch handle itself. If you don't have the water cool, as those many have found out, it gets pretty hot and it just stays hot for a while and has to naturally cool itself down. Let's go over parts of the torch. So the first thing is your collet. That's this little part right here, and this actually holds your tungsten. You have the collet body, which holds the collet. Your end cap, so here's your end cap, backstop or tail, rooster tail. It has a bunch of different names. You have your torch body, which is the actual torch with the handle. The gas nozzle, which is your, gas nozzle, obviously. And then there's a gas lens that actually goes inside of a specific type of gas nozzle. Let's talk about your setup. So you have your shielding gas that goes to your flow meter, and then that is fed into your welding machine. Your welding machine will have the shielding gas that goes to the torch, and then you'll have your ground or your workpiece lead that goes over here, and then you have your electrode lead that leads into the machine or into your torch or onto your ground, depending if you're negative or positive. Over here you have your base metal, you have your torch, you have your welding rod or your filler rod, they're different names. And if you're using a foot pedal setup, you would have a foot pedal. If it is a water-cooled torch, it is pretty much the exact same setup. The only difference is that you have a water setup or a coolant. It could be water or coolant that comes in and feeds into the torch, cools off the handle, comes back out, and lead somewhere else. Now, the one that we have in the shop has its own little tank where it feeds in, loops, and then goes back to the tanks, and then it kind of loops. So it's kind of like a radiator for your vehicle. Next, you have your inert shielding gases. So the one that we're using is argon. It's easier to start, maintains a good arc, covers the weld area better in the flat position, and is less expensive. And then you also have helium. Now this is where the term heliarc comes from. It gives you a much hotter arc, and you can travel a lot faster, but because it's helium, it's much more expensive. So if you can tell, argon, when it comes down, because it's heavier than air, will actually cover out and it will try to flow over. That's why it's better in the flat position, but overhead it's actually a little bit worse. Helium is lighter than air and will actually try to float away. So in the flat position, helium isn't the greatest, but in overhead it is phenomenal. The difference is because this weld at a hotter arc, you might have to use a lower temperature or you might have to use a bigger electrode. Safety precautions of argon: it displaces oxygen, just like other gases. You want to make sure you have good ventilation if you're in a closed area to remove the shielding gas and to supply fresh air, because this is going to move the oxygen out and it might suffocate you. So we have regulators and flow meters. Regulators reduce the cylinder pressure to usable pressures, and then the flow meter, which this is the setup that we have, measures gas flow in CFH or LPM. CFH is cubic feet per hour, and LPM is liters per minute. There's different calibrations for argon and helium. If you actually look on the side of your flow meter, you'll actually see where it says like carbon dioxide, or it'll say argon on one side and then it'll say helium on the other. Now let's talk about post-flow. For some metals, especially something like aluminum, you would have a post-flow, which once you stop the arc, gas is going to keep on going to protect the area and protect your electrode. So protect the base metal and the electrode. And it helps prevents the weld from getting contamination and your electrode getting oxidization. So very important for something like aluminum or stainless steel, which if you get contamination in it, it's just gone bad. We have remote control devices, so like a foot pedal or a thumb switch. It turns the current on and off. If you're using touch start, you just touch it to the metal, but with a foot pedal or a thumb start, you just hit it with your foot or you just click it and it will turn the current on. You can use it to adjust how much current is flowing in. It turns the shielding gas on and off. And it makes it a lot simpler and easier to not get contaminated. And then the next thing is what type of equipment you should have. Obviously, you should have eye protection, so a welding helmet with a number 10 to 14 lens. Clear cover lens in front of the shielding lens, a flash goggles, a number 2 lens under a helmet. So if you're using auto darkening, you might want to have a slightly tinted safety glasses. And then, of course, you want to have your correct clothing, so fire-resistant, long-sleeve shirts and pants, thin gloves, and non-flammable objects in your pocket. So if you have a lighter, you want to get that out. Other things that you should probably not have on are rings, necklaces, nose rings, earrings, tongue rings, belly button rings, all those type of stuff like that. Shouldn't have those on while you're welding because they can arc off if you become grounded. But the cool thing about TIG welding is if you just have a long sleeve shirt on, it works. As long as it's something that's not going to get burnt up. You don't want to wear polyester or nylon. So that is the end of lesson 19. If you have any questions, just let me know.